This video is going to show us how to change improper fractions to mixed numbers. I've already have another video as well, but it's a different strategy. So you will see a different strategy in this video than the other one if you have happened to watch it. Just to recap, improper fractions are fractions that have a greater numerator than denominator. Example, 21/8, 8/5, 4/3. Mixed numbers are numbers, two different types of numbers that come together to make one number, a whole number and a fraction. So mixed numbers are whole numbers, as you can see the whole number 6, with a fraction 1/4. All right, so the strategy that we're going to work on in this video is division. We are going to use division to help us convert our improper fraction to mixed numbers. So if you notice, this is an improper fraction because the 7 is larger than the 5. Now, this reads 7/5. However, this is also noted as a division bar. And because of that, we can also read this as 7 divided by 5. So, if we set up, now I'm going to use partial quotient division and not long division. I'm going to use partial quotient. It looks very similar. And I'm going to do 7 divided by 5. So I have 7, and I want to make 5 groups, basically. So I ask myself, 5 goes into 7 how many times? Goes into it 1 time. 1 times 5 is 5. I subtract, and I get a remainder of 2. So, with this strategy, the mixed number is composed of the quotient with your remainder over your divisor. So, let's look here. Our quotient is 1 with remainder 2 and divisor 5. So my mixed number for 7/5 is 1 2/5 using division. Now, the higher the numbers, the more complex that could be, but it seems to be a quicker strategy. It does not involve as much conceptual thought or breakdown of the fractions like decomposition. So it seems to go a little bit quicker. So let's try another one. I'm going to use larger numbers, and it helps for the questions like this, where you don't have to draw out or write out 21 tiles with half in them, or you don't have to decompose and write 21 halves, add all those, circle your holes. This just seems to go a little bit quicker. So with division, we would then take our numerator and divide it by our denominator. So, 21 divided by 2. Partial quotient division, again. Some people could do this mentally, but if we're wanting to show how we got our answers, this is how we would do that. I start in the highest place value, which is the tens. I have 2 tens. How many times will 2 go into 2? 1 time. But I'm dealing with tens, so I have to make that a 10. 10 times 2 is 20. So I subtract that to find out that I have 1 remaining. So 2 doesn't go into 1, therefore this would be my remainder, because my remainder is smaller than my divisor. So I go back to my guide, that it's quotient, remainder over divisor. So my whole number is my quotient, my numerator in the fraction is my remainder, and my divisor is the denominator. So it would be 10 and 1/2. 10 1/2. Let's do one more, an even larger number. 34 divided by 3, or 34 thirds. Clearly improper because the numerator is greater. So it would be 34 divided by 3. If we put that into a division problem, it would be 34 divided by 3. Three goes in to 3 one time, and I'm dealing with tens. 10 times 3 is 30. Subtract that. I get 4. 3 can go into 4, so I'm not finished. How many times does 3 go into 4? 1. I'm dealing with ones because I only have the digit 4. 1 times 3 is 3. Subtract that. I get a remainder of 1. I am now finished because my remainder is smaller than my divisor. So, to get my quotient here, if you'll remember, we add these partial quotients, and it's 11. So, my whole number would be my quotient equals my remainder over my divisor. So, quotient is 11, my remainder is 1, and my divisor is 3. So, 34 thirds is 11 and 1/3. This can also lead to doing this mentally, which is perfectly fine. So I showed you the strategy, which we call that tools. Those are tools. Those are things that are made for the purpose exactly for that purpose. But there's also tricks that help us do things quicker. So if I have 15/8 and I just want to do this quick just to get it converted to help me use it to add or subtract or whatever I'm going to do, I divide. 15 divided by 8 is 1. How many are left over? 7. Keep your denominator. That's the trick. Show you that one more time with a different set of numbers. 28 over 5. 28 fifths. 28 divided by 5 is 5. If I have 5 times 5, that's 25, so that leaves me with 3 fifths. That's the trick. This is a second strategy. Either strategy works the same. They are the same concept. One is more complex as far as writing it down than the other, but they both will help you to convert improper to mixed number. You choose what fits your learning the best.